time. Let's look at Mepdg. I'm going to be using throughout today Mepdg, Mechanistic Empirical Payment Design Guide, and Pavement ME software interchangeably today. They're not the same thing. Mepdg is a guide, Mechanistic Empirical Payment Design Guide. G is guide. So you have a book, you can download it, you know, this is how you do it. Pavement ME is the software that implements this guide. So it's the same thing, but a Pavement ME is a software, all right? So, but I will be using them interchangeably, which is fine. What you're seeing is the plans for using Mepdg. There was a software survey back in 2014, and on plans on using Mepdg throughout the United States. So some of the states already implemented. Some of the states are considering, were considering, I mean, this is 3 years ago, but we're considering implementing. Some of them says we are not going to do it. And some of them said we will do it maybe 2, 3 years, 4 years from now. So it is right now, it's not exactly clear what's going to happen in the whole United States. There is a more updated map. So if you look at Michigan, I'm going to put the spotlight on you guys. You can tell me where are we relative to this. Are we going in that direction or in Michigan, or are we still?
We're on hiatus right now because I can go really deep into this, but I'll just say this. They update the software continually, so we have to recalibrate continuously. And so because of this, we just recalibrated to version 2.3. And we were on 2.0, we were calibrated back in 14, so we were implemented. They updated the system. We just now finished our research project with MSU to recalibrate us. And so we're going to try to start using ME again for our design decisions. However, we're releasing another new package in January and another one in July. So you can see how this is becoming a continuous problem for us. So I'll go into that later on if you want me to. But anyway, so yes, we're on a hiatus right now.
Okay, all right. So maybe that's a lunch discussion kind of a thing. All right, so it's the same. There are okay. That's me being too loud now. I was trying to increase the volume of your mic. Okay, all right. No, it's too low, or okay. Okay, all right. This is better. All right, the same thing exists. Same kind of a problem because of recalibration. Whenever there is a new version of the software comes in, there are some needs for recalibration. That's certainly not nice in a sense, right? So it's a lot of work every single time. It's nice for universities though; they like to. But anyway, this year, in terms of a couple of weeks ago, yeah, actually about a month ago or so, I contacted the AASHTO and I asked them what kind of licenses, they didn't tell me who implemented, but they told me that these are licensing. So there are, almost entire United States is trying the Pavement ME software. So they're actually working on it. So actually this workshop, you're right on time, because Mepdg is not fully implemented, but it looks like it's going that direction, and things change very slowly in our industry. So going from one payment design approach to another, it's very, very difficult and it takes slowly, but we are in that right direction. Whether that's going to stop or not, I don't think it's going to stop. Eventually, with all these hurdles, eventually we will go to Pavement ME type software. You can see California, great country of California, is, did I say country? State of California. All right, so they're not licensing, and there's a reason for it, partially. They have a very nice software called CalMe, California Mechanistic Empirical. It has advantages over the Pavement ME, and they really like it. And Pavement ME has advantages over CalMe also, but CalMe, they have their own software, so they feel comfortable. I believe that might be the reason, but right now they're not licensing. I don't know what they're going to do, and there are couple more states that and the Illinois also have a software. So but the thing is, the reason why they're not licensing is mostly because they have their own mechanistic empirical software. So it is important to have a mechanistic empirical design procedure. And all these procedures, at the end of today, hopefully, you will see that they have lots of things that are common. Structural analysis is one of them, okay? You do the structural analysis and then do distress analysis, and there are different approaches that different models use. Now, this is Canada. So so they are not so yellow areas are licensing right now. Again, this is very recent from a month ago. Quebec have not renewed their license yet, but they have been licensing. These blue areas are not licensing in Canada. Okay, how about Europe? In Europe, mechanistic empirical payment design guide. The rest of the world, they are not using payment-me. I mean, they are not there yet, but they have their own methods. One thing, let's start with the climatic regions in Europe. So there are hot Mediterranean climates like Florida, Texas type. This area is quite warm. Greece, blue areas, cold. This is supposed to be blue. I don't know why it's not blue, but this is supposed to be blue. Cold countries in the Northern Europe, they're very, very cold. Green areas and the yellow areas. So depending on the climate, different European countries use different types of methods, and they're all different countries, so they all use different methods. Now, there was a survey by World Road Association. So they said, I apologize for the blurry. I couldn't find a better looking graph here from their report, but apparently most of the designs in Europe are analytically based. It's basically limiting the strain at the base of asphalt. Some of them are empirical, some of them did not specify. And among these analytical methods, most of them also use linear elastic solution. Some of them use nonlinear elastic solutions. So it looks like some of the countries in Europe, they're actually using nonlinear elastic solutions for structural analysis. The other ones did not report. So this was interesting. When I saw this was interesting because I would always assume that empirical would be the most, but they are using analytical approaches most of the time. Now, France, if you look at France, they use a linear multi-layer elastic model, Burmister's model, to calculate the tensile stresses and strain at the bottom of the bound layers. Bound layers meaning asphalt layers. So they look at the stresses and strains at the bottom of the asphalt layer. And then they also look at compressive stresses, vertical compressive strains at the top of the unbound layers, so essentially base, induced by a certain 130 kilonewtons at 15 degrees Celsius. So they have a modulus that corresponds to this value, an average modulus for that area, and that they use that in their designs. And they use 4 classes of bearing capacity of the subgrade. Germany, they use, so they first look into frost resistance, and then in terms of, there are certain specifications on load bearing capacity and degree of compaction. What thicknesses are based on like a catalog type approach. There are different design types it's like they choose from a catalog. So it's more empirical. Poland is mechanistic, interestingly, a catalog of also flexible pavements. They have flexible pavements, but this catalog is developed based on a mechanistic model and calculations of typical structures in that area. And they also use a multi-layered elastic model. There is no such word as C-elastic model. I'm sorry. Can we correct this? Should be elastic. Please correct on your notes. A multi-layered elastic model is used to calculate the horizontal and stresses and strains at the bottom of the asphalt layer and vertical compressive stresses and strains at the top of the subgrade. So total thickness of the asphalt pavement design is designed to limit fatigue cracking not more than 20% at the surface and rutting not more than about ½ an inch or so. So these are the limits, and they've run a whole bunch of analyses and came up with the catalog, and that's how they use it. Yes? Yes, this is pavement ME, mechanistic empirical pavement design guide type. So running the pavement ME mechanistic empirical design guide many times and coming up with standard thicknesses for different type of regions. Empirical, this is AASHTO 93 type. When I say empirical, usually AASHTO 93 type. Mechanistic is typically pavement ME type designs. Australia, they have pavement ME type. Design method is an analytical approach employing a linear elastic program, CIRCLI. So this is the pavement ME software equivalent in Australia. It's not the same, it's a little bit simpler, but it's different. One important improvement over pavement ME is stress dependence of the granular material is considered. So in pavement ME, you can also consider this, but CIRCLI is pretty good at this also. And granular layers are divided into sub-layers with stiffness modulus of a layer up to a limiting value. So you can simulate the structure with increasing modulus. Generally, direct measurement of a material property is preferred, but shell nomogram can be used to estimate asphalt stiffness modulus. And the charts in the design guide have been established using the shell asphalt fatigue criteria. So their software is based on shell method. I'll talk about the shell method a little bit because the pavement ME uses something similar, somewhat similar. Japanese method is an empirical method based on AASHTO raw test. They just use the AASHTO 93 design slightly modified in their conditions. So I'm not going to read all this, more like we'll for reference purposes for you. New Zealand is also shell method. Again, I'll talk about the shell method, very similar to the mechanistic empirical pavement design guide. Now, shell design method is based on first published in 1978. So in here, subgrade strain criterion was determined from an analysis of AASHTO raw design test. So there is a strain condition that needs to be limited to a certain level. Fatigue criteria is based on a lab test and multiplied by a shift factor to account for effects of climatic loading conditions on the road. And measured fatigue characters can be used, but they are used to obtain a nomogram. So shell design method is essentially you use a structural design structural analysis program to find stresses and strains at the bottom of the asphalt, and there's an equation that relates number of cycles to failure to the strain that you have there, and that particular equation is calibrated, quote unquote, calibrated to AASHTO raw test kind of a thing. South Africa is based on again AASHTO procedure, and there is basically E-cells are calculated from again from an 80 kilonewton road, and they have a whole bunch of different CBR values that they use in that zone. Now, there is a report by World Road Association. It's called Cost Report 333. What they did is, this was an interesting slide. I didn't want to pass on. They said, okay, they sent a design challenge to all the European countries, and they said, okay, design a pavement that will last 100 million E-cells, kind of a thing. So these are all the different designs that all different countries that came up with. Okay. Do you see any uniformity here?
Same CBR.
Yeah. So there's always, so if you replot this graph in a like a reducing order. So these are the asphalt thicknesses, 6-inch and 12-inch, and so it was all over the place. So different places have different designs. Okay.